Okay, we're going to be going through some probability questions. Uh, with every question, you can pause the video and have a go at it yourself. But with some of the more complicated ones, I'll be stopping and doing some extra explanation throughout the question. So let's begin. A number is picked at random from the first four prime numbers. A number is picked at random from the first four square numbers. The two numbers are added to get a score. Complete the table. So there's four essentially 3 marks. You have the first four square numbers, start on the top row, 1, 4, 9, 16, and the first four prime numbers, 2, 3, 5, 7. And you just add, come across, so 3, 4, 6, 8, 6, 7, 9, 11, 11. This one's already done. 14 and 16, 18, 19, 21, 23. It's pretty simple, just adding the numbers, pretty simple stuff. What is the probability that the score is a prime number? So what we can do here is out of the 16 possible outcomes, 4, 8, 12, 16, we have to find all of the prime numbers. So what's easiest if you have a different colored pen or a pencil, just go through and find every prime number. So 3, 11, 7, 11, 19 over there, and 23, 3, 4, 5, 6. So that comes out to 6 out of the possible 16, which can be simplified, both sides divided by, both numbers divided by 2, 3 out of 8. So your answer is 3 out of 8. Next up, a spinner question. Uh, if the numbers the arrows land on are different, the score is the higher number. If the numbers the arrows land on are the same, the score is 0. So once again, this is another filling in the possible scores, but with a different quote-unquote rule set this time. So again, simple stuff. So I think the easiest way to do this is to fulfill one condition first, or one sort of rule. If the numbers the arrows land the same, the score is 0. So there's only one common number, which is 2 and 2. So you find 1, 2, and 2, they've already done. The other 2 and 2, you put 0, since the score is 0. And if they are different, the score is the higher number. So once again, you can just go through and complete this. I'm going to do it myself now, just to finish the question. 4, 6, 5, 7, 6, 6, 7, 9, and then 8. Oops, I think I've done this wrong actually. My bad. We're not adding the numbers. That's my bad. We are choosing the higher one. So let's start again. 0, 0, 2, and 1. The higher one is 2. Higher one is 3. Higher one is 5. Higher one here is 3. Higher one here is 5. 2 and 5. Higher one here is 4. 4. 4 again. 5 here between 5 and 4. 6 and 2, 6. 6 and 2, 6. 6 and 3, 6. And 6 and 5, 6. Write down the probability that the score is an odd number. So same thing here. I have to go through and find, let's make this a little bit clearer. This is a 0 because it's a 2 and a 2. 0. So we go through. Once again, we mark all the odd numbers. So we have 3, 5, 5, 5, and 3. This is all 6, this is all 4, this is all 2, this is all 0. 1, 2, 3, 4, 5. So our answer is 5 out of, remember, our possible 16. So 4, 4, 4, and 4 are 16 possible outcomes. 5 out of 16. Okay, a dice question. Pretty common. I'll go through this one fully first. Again, you can pause and go through it. So a fair dice has 6 sides, numbers 1 to 6. Okay. After it is rolled, 5 of the numbers can be seen. So one of the faces is facing down. Write down the probability that one of these 5 numbers is 2. So you may think that the answer is just straight up 1/6. There's 1, 2 out of 6 numbers. That's incorrect. The best way to think about this, in my opinion, is to think instead of thinking the probability that 2 is amongst those 5 numbers that you can see, think about the probability that 2 is not amongst those 5 numbers that you can see, meaning that the 2 is facing down. And if it's a fair dice with numbers 1 to 6, 6 sides, the probability is 1/6. So what you've done, if the probability of a 2 complement or not being 2 is equal to 1/6, then the probability of you being able to see 2 is 1 minus the probability of no 2, which equals 5/6. Next, they ask you to work out the greatest possible sum of the 5 numbers. This is a real probability. You have numbers 1 to 6, and you must choose 1 to remove to get the greatest possible sum. It's going to be 1. One gets removed, and you get 2. Adding the numbers from 2 to 6, which equals 20. You can see 2, 3, 4, 5, and 6. Pretty intuitive stuff right there. Next up, a cards question. This one I believe was from an end of a paper, question 21, near the end, so slightly trickier, but if you just apply your general principles and remember the basics, it should be pretty simple to get through. So, 2 of the 5 cards are picked at random from these 5 number cards. So, the first thing we do with this kind of question is work out what we're out of, because the total of the numbers must be out of it. So, the total number of combinations we can have, it will either be 4 times 5 equaling 20, 5 times 4, or 5 times 5 equaling 25. And it can only be one of these. The answer is the one on the left, because we're assuming that the cards are taken without replacement. So first, you have any of the 5 cards to choose from. 5. You remove 1, you pick 1 up, and you have 4 remaining to choose from, which gives you out of 20. So the next step in this question is there are 20 possible combinations of these cards when you pick one and then pick another. The next thing to do is to figure out which of these combinations satisfy this condition that is more than 30. So the first thing that you would do would be to take your first one, 17, and see how many of the other cards. So imagine you pick 17, how many of the other cards will give you what you need, which is being more than 30, and is not 12, but 23, 15, and 16. If you add these up, if you add 23, 17, 15, 17, 16, 17, you will get more than 30. So 17 gives you 3 possible combinations, successful combinations, rather. Going next to 12. 12, you picked up 12. How many successful combinations do you get? Well, 17, you can't. 15, you can't. 16, you can't. There's only 1. So 12 gives you 1 combination. Next, 23, you picked up 23. If you pick up any of these cards from 23, after 23 rather, you will be able to get more than 30. So for 23, we write 4 successful combinations of 23. Next, 15. 15 has 23, 17, and 16, but not 12. So let's write 15, 3. And lastly, we have 16. 16 has everything except 12. So once again, 16, 3. So then we add up these 3, 6, 9, 10, 14. 14 successful combinations out of a possible 20. Okay, next up, a good old Venn diagram question. These are quite simple. If you do the Venn diagram correctly, if you draw the Venn diagram correctly, you will definitely get 3 marks. In this case, even better, they've done it for you. But you have to pay attention. They're always trying to trip you up. So let's have a detailed look at this diagram. It asks you to work out the probability of complement of A union B. So everything which is not A, so all of this stuff out here and here, remember this bit in here is A, and all this stuff in here, union, so added to everything that is B. So all of this stuff in here is B. What they're not telling you is that if you do 0.3 plus 0.15 plus 0.35, you will get 0.8, which is not add up to 1. And if it's in the sample space, something must happen. So 0.2 going out here is the chance that nothing will happen, or neither of these two things will happen, rather, not nothing. So what you have to consider is this 0.2 outside. So you wouldn't do, for example, 0.15 plus 0.35 equals 0.5 and forget it, that's your answer, because you haven't considered that this stuff out here, the 0.2, that is also not A. So you have to include that when you unite not A and B. So your real answer would be 0.15 plus 0.35 plus 0.2, giving you 0.7, and your answer is 0.7. Okay, this is another tree diagram question. I'm gonna leave this one a little bit more to you since we've already done one of these. But this one is slightly different, slightly more intricate since it uses 3 events. So Felix has 10 cards. There are 5 red cards, 4 blue cards, and 1 green card. And he takes one of the cards at random, not replacing the card. Always pay attention to this, not replacing the card. Felix then takes at random a second card. Okay, so there's only 2 2 events, which is nice because there are 3 different things that can happen per event. Complete the probability tree diagram. And this is the only part of the question. So this essentially just requires thinking clearly and moving slowly, taking your time. Remember, this is free 2 marks, and there's no rush, but it's very easy to make a mistake when they are not replaced. So moving slowly from the top, if we do 5 over 10, this would not then be 4 over 10. It will not be that, because remember, the card is not replaced. So there are now a total of 9 cards left. You've chosen a red one. There's 1 less red and 1 less total. 4 over 9. Then we go back to red. 5 over 10. So the number of blue is unchanged. There are still 4 blue. This is 4 over 9. And green, same as blue, unchanged. You've gone down the red path. 1 in 10. But if you spotted it, if you've been paying attention, it is not 1 in 10. We have not replaced the card. It is 1 in 9. Next up, we've gone on the blue path, 4 out of 10. Number of red is unchanged. 5 out of 9. Blue, we removed 1 blue, and we removed 1 from the total. So this becomes 3 out of 9. I prefer to keep it as 3 out of 9 to keep it all out of 9 consistently throughout the tree diagram. And then green is unchanged, 1 out of 10. Instead of 10, it's not 10, it is, in fact, 9 still. Now we go down the green path. Red is unchanged, 5, 9. Blue is unchanged, 4, 9. Green, however, there is only 1 green card, and now you have taken it. Therefore, the chance of you choosing another one is 0. You have to write 0 out of 9. That doesn't make sense. Just write 0. So remember, the non-replacing, that is the most important part. That's where you will lose marks in the event that you do. So pay attention to that. Take your time here. Remember, this is coming sort of midway through the paper, so you should start to calm down, relax by now, but it's still quite easy to make a mistake. So do be wary of that. And I think we're just going to jump straight into this next one. There are 25 boys and 32 girls in a club. 2/5 of the boys and 1/2 of the girls walk to the club. So 2/5, and writing down as you go along is a useful tactic. 2, this is walk. The club leader picks at random a child from the children who walk to the club. Work out the probability that this child is a boy. So here, am I going to do 25 plus 32 and then take the people who walk out of that? Whatever that be, so that would be 25 plus 32 and then 2/5 times 25 plus 1/2 times 32, which would be 26 out of 50. Am I going to do that? Or am I going to read the question carefully and say that the club leader picks at random a child from the children who walk to the club? So it's not out of all the children, 57. We can keep that 26, it's useful to us because from the children that walk to the club, we do out of 26, and the probability that this child is a boy, so we want boys who have walked to the club from children who have walked to the club. So we do 2/5 multiplied by 25 over, sorry if that's a little messy, but can't really be helped. 2/5 times 25 over 26. 2/5 times 25 is 10 over 26. That's a probability. It can be cancelled down to 5 over 13. These can both be divided by 2. And that's your final answer.